All right, so here is another example problem to hopefully help you differentiate between average speed and average velocity. So here it says there's a jogger that's going to go from point A to point B in the innermost lane. That's lane 1 along a standard track in 58 seconds. And it wants us to find A, B, C, and D. And then part E says if the jogger goes from B to A in an additional 36 seconds, and it wants us to find the average speed and average velocity. Okay, so if you need to pause, read. And that, let's get cracking with part A. So to do part A, the problem didn't specify which way the jogger is running, so I'm just going to stick with the traditional or standard here direction of motion in a track race. That is to go in this diagram along the where my cursor is tracing. That would be in the counterclockwise direction. Okay, so I'm just going to assume this is the direction of motion, because if you do the opposite, then the answers will be different. So I'm just going to kind of go ahead and indicate that this is the direction of motion here for this particular problem following a typical high school track race. Okay. Other than that, let's go ahead and do part A. To find the total distance, you would have to first find the distance of this first semicircle, add it to this leg, the straightaway leg here, and then add it to another quarter of a circle. Okay, so from this segment here all the way to B, that's a 1/4 of a circle, so a quadrant. All right. So the generic function for a circumference of a circle is 2 pi r. I'm going to apply that to find the distance of this first semicircle by just doing half of a circle. So I'm just going to call this distance d. D here is 1/2 of the total circumference. And then r here being the radius, which is given in this particular diagram as 36.5 meters. All right, so the 1/2 here is going to cancel out with the 2 in the circumference function. So really it just reduces down to just pi r. Once again, pi r is the distance from A all the way to the other side of the curve. Okay, so that's just the first segment. So I'm going to chunk this down in 3 segments. All right, so you plug and chunk here, r being 36.5 meters, and take that and times it by pi. In decimal, you'll get about 114.67 meters. So that is just the distance from this first semicircle, but it wants us to find the distance from A to B, so we need to add the other 2 segments. So I'm just going to label this. So I just found this distance here to be 114.67. The straightaway leg is given in the diagram as 84.39, where I'm circling back and forth there. So I'm just going to label that. That's the straightaway. And then this other leg, which is 1/2 of a semicircle, or you can do 1/4 of a circle. Okay, so this right here. I already found the distance for the semicircle, but since this is half, I'm just going to take that value and divide it by 2. So once again, the 114.67, I previously calculated it on the right side here, and then I'm just going to chop that in half because it is half of that distance. Okay. All right. Other than that, I'm just going to add all the values. So 114.67 plus the straightaway, which is 84.39, plus 57.34 meters. So if you take your calculator and you simplify this fraction that I'm circling back and forth here, 114.67 divided by 2 gives you about 57.34. And if you sum that up, the total distance in this case would be 256.4 meters. Okay, and distance is a scalar quantity, so there's no need to include directions. All right, let's do part B. Okay. Part B wants us to find the displacement. So once again, displacement is a little different than distance, especially if it's a 2-dimensional problem. So to find displacement, I'm just going to draw a line or an arrow that connects from start to finish. So you notice here my arrow starts at point A and it points towards point B. So I need to find what this length is. That's your magnitude. Okay. So to do that, I'm just going to make it into a right triangle. So the information here is given. The base here is going to be 120.89. That's because I need to add both these lengths in the diagram here to give me this full length on the bottom. Okay, so you need to kind of think about that again. And then the rise here, that would just be the radius of the circle, which is given as 36.5 meters. Now that I have the 2 sides of this right triangle, I can just apply Pythagorean theorem. So a squared plus b squared is equal to c squared. It doesn't really matter which leg you call A and B. I'm just going to call my A as 120.89 and my B here is 36.5. Make sure you square that properly, add it up, and then take the square root of that. So here, just to save work, I just went ahead and add all this up on my calculator and then square root both sides just to get C by itself. And then if you do that, the square root of, what is this, 15,946.64 will give you approximately 126.28 meters, okay? So that is the length of that hypotenuse, or the magnitude of your displacement, if you want to sound fancy. Well, part B asks you to find displacement, which is a vector quantity. Keep in mind, a vector quantity has to have a magnitude and a direction. Well, I just found the magnitude. So the 126.28 meters here represents the magnitude, but you need the direction. So in this case, because you have a triangle, you do have to find the angle that touches the horizontal axis. So here is where I label theta. Well, to find that theta, I can just do tangent. That's because the diagram gives me my opposite, and the adjacent I already have just simply by adding really the information in the diagram up. Okay, so opposite in this case would be 36.5, and my adjacent is 120.89. Well, to solve for theta, I just do inverse tan of the function. So therefore, if you plug this value in, and hopefully you calculate this in degree mode, and if it's in degree mode, you should get an angle of approximately 16.8 degrees. Okay, so this is the proper way to express your answer for part B, because it did ask for displacement and it didn't use the word magnitude, so you have to have magnitude and a direction. So I would just say that the proper way to express this would be 126.28 meters, and then it would be 16.8 degrees northwest. So it's important that you include this northwest, just to the person looking at this can understand, which way the arrow is pointing. Okay, so it's not sufficient to just put 16.8 degrees. You have to specify the direction as well, the orientation of the vector. Okay, that is the answer to part B. And then part C asks you to find the jogger's average speed. So this is pretty light work. I'll just do it up here. So average speed is simply distance divided by time. Well, we already know the distance. We already calculated it from part A, which is 256.4 meters. And then the time is given in the statement as 58 seconds. And if you simplify that on your calculator, you get approximately 4.42 meters per second. And average speed here is a scalar. So therefore, the magnitude is what you're looking for. Okay. Let's do D and E. D asks you to find the jogger's average velocity. So not bad at all. So just apply the average velocity function. Average velocity is by definition displacement over time. Well, we already calculated the displacement, right? This diagonal here is your displacement, which has a magnitude of 126.28 meters. So all you have to do is plug delta x in, as 126.28, because that is the magnitude of your displacement. And then how much time did it take? 58 seconds, because it was given in the problem. And if you simplify this, you'll get a magnitude of 2.18 meters per second. However, you're not done yet, right? The wording says determine the jogger's average velocity. It didn't say magnitude of the average velocity. It just says average velocity. And velocity is a vector, so you have to have a magnitude and a direction. So keep in mind, we already found theta here previously, and that angle was 16.8 degrees, and it's pointing northwest. So to properly present your answer for part D, you do have to include the direction. So the 2.18 meters per second is your magnitude, and then the direction in this case would be 16.8 degrees, pointing in the northwest direction. So that is your overall answer for part D. So make sure you understand when things, how things are asked, whether it's a scalar quantity or a vector quantity. So if it's a vector, make sure you include direction and be really, really mindful of that. All right, let's do E. E here says if the jogger continues along the same path. So really finishing one lap here, right, from B all the way back to A. So really running one complete lap, and from B to A takes an additional 36 seconds. It wants us to find the total average speed and the total average velocity. This is pretty light work. Average speed, once again, is just total distance divided by time. Well, we can find total distance pretty straightforward, right? You have two straightaways, so there's the two in the front. Each straightaway is given in the diagram as 84.39 meters. And then earlier, I already found the distance for a semicircle, right? So in part A, I spent time doing the semicircle there, which turns out to be 114.67 meters. But there are two semicircles along this track, so that's why there's a 2. So really, symmetry-wise, there are two straightaways and there are two curves. So that's why there are 2's in both of these quantities in the numerator. And then for time, I just added 58 seconds plus 36 seconds. because that's how much time this particular jogger took to complete this one lap. All right, so if you sum that up, the numerator gives you about 398.12 meters, and then the total time is 94 seconds. And for the simplification, we'll give you about 4.24 meters per second, and speed is a scalar, so I'm done there. Now, let's do average velocity. Well, again, you just have to learn how to apply these physics functions and stick with how things are defined. Average velocity is different than average speed, especially for a two-dimensional problem. So displacement, well, displacement is your change in position. However, if you start at point A and you ran around this lap, around this track, according to the direction of my cursor here, and you end up at point A, well, if you end up at the same position, there hasn't been really any change. So your delta x here would just be 0. So it's okay if your displacement is 0. Your displacement is 0 if you start and stop at the same position, because you're back to where you started. So you haven't really, quote unquote, changed location. Okay? So the delta x here is just 0. I just, for technical purposes here, put t as 94 seconds, but who cares? If your numerator is 0, dividing by whatever is still going to give you 0. So 0 divided by 94 seconds would just give you 0. So your average velocity here would just be 0. And you notice here there's no direction because, well, you're back to where you started. So there's no arrow to draw. And because there's no arrow, there's no need to include direction because it doesn't exist. And that is it for this particular video. Okay? All right. Stay nerdy. Don't be wired.